Well, hello friends. Today we are going to try to make an strace for Serenity. Um, and I am not quite sure how we're going to do that, but we will just figure it out as we go. So strace, of course, is this thing that shows all the system calls that another process makes. And someone suggested it in a comment that it might be useful, and I totally agree. So we should make one. Let's start with adding, let's add a binary for it. Call it strace cpp, and I'm going to edit it in QCreator actually. And let's just flesh out sort of how we imagine that this would work. Let's say that we only support calling it with an existing PID for now. So that would be something like, well, if it's less than 2, then just return. RHV1, A2. Okay. And you are in stdlib. Okay. And then, let's see. So let's say that we have something that gives us a file descriptor like this, right? And then, how does this work? Well, let's just handle the error. Return 1, error, strace. Okay, and then we'll just read from the thing. And let's see, so syscalls right now, this is where, or actually this is where we enter the kernel and this trap handler here, which is an x86 interrupt service routine. It just calls this guy here, which takes out these 4 relevant register arguments. So it's EAX, EDX, ECX, and EBX. And the function is an EAX, and these are the 3 arguments. So I think that that's what we're going to do, is we're just going to have it be a stream of these 4 32-bit D words. So we'll say call 4, and then we'll do call, size of call, and red is, I guess if it's 0, then we break because it's end of file. And oh, D word is not defined. There we go. And otherwise, if nred is less than 0, p error read return 1. Otherwise, if nred, oh, let's just assert nred is size of call. And let's include assertions. And finally, let's printf. Let's see, how do we print this? Let's just print it out with like function x arg1 x, or arg the yeah, so this will be a pretty good start, I think. And call 3. That's cool. And let's go ahead and be good boys and close it. Even though close never actually fails on this system, maybe in the future I will add some reason why it would fail. I don't know, if I had NFS or something. Okay, now we're going to need to actually define this thing. So let's put it here. Systrace. T. Okay, and then in unistd, we will add it. Strace. It's just going to be this typical Syscall. Okay, and just PID. Okay, and now we got to go and actually implement this Syscall because currently it doesn't exist. First thing we do is add it to the big Syscall enumerator thingy. So that goes there. And then we are going to need a entry point in the process class. And that will be here. And Systrace. T. Okay. And then in Syscall CPP, we have to actually look for the Syscall number and dispatch the handler. So Systrace, return current process Systrace. T arch1. Cool. Okay. And then in the process class, process Systrace PID. Okay. So we're going to need to disable interrupts here because we need to look at the process table. So let's see. Let's call it the peer process. From PID. If there is no peer, return enosearch. Oh, eSearch. That means that there was no such PID. And if peer UID is not UID, if it's not my effective user ID, then access. Let's say, or let's say eperm, or no, it's eaccess. Okay. And then what do we do? Now we need to allocate a file descriptor. And if we couldn't get one, what is it? M file? Is M file the one we do? Oh, right. If it's less than 0, we just return that thing because it will contain the problem. Here, yeah, see, M file. Oh, okay. Now we need to create some type of object that can be stored in a file descriptor that you then can read from and receive the syscalls of another process. So I guess we'll call it something like trace, just trace, why not trace? Okay, process syscall trace. Create, or no, hold on. Let's let the process deal with it. So the peer should create one. Tracer. We'll call it tracer. Yeah. Should we call it ensure tracer? No. Okay, and then auto descriptor is file descriptor create. Yeah, well, this is what we should do. So then file descriptor should be able to have a tracer, whatever a tracer is. And then, God, how is it that we set this up? MFDs. This is dot set. God, what does open do? Yeah, it does this thing, right? So MFD, ZD set, move descriptor, no flags, whatever. Okay. And then we return 0 if that works out. Okay, now process needs to have some kind of a tracer, whatever that is. So let's just call it process tracer. Yeah. We can just put one here. I'll say process tracer. And maybe it should be something that can be retained. And tracer. Okay. And process tracer. Actually, we should make this thing return a reference because we're always going to succeed. So let's do it like that. And let's see if mtracer is process tracer create this. Okay. And then return mtracer. And now file descriptor needs to have a static retained file descriptor create that takes a process tracer. Retained. Okay. And I put you next to this guy, process tracer. And you will go down here. Even though you don't really exist yet, we will still have a member with you in it. Okay, and then we'll add a constructor for it. Okay, we need to get to answering the big question, what the heck is a process tracer? Eventually. Should that be const? No, it shouldn't. But it can do tracer get. No, mtracer putter. Tracer. And we'll add a const overload because we'll probably need it. Okay. And still not gonna actually make that class, and I'm gonna figure out how I want to use it first. So then here in the trap entry, when we call Syscall handle, we can also, let's see if current process tracer, so yeah, so we're gonna need to actually break that up, back up. So we'll add a tracer, and we will have an ensure tracer, and this one will just be mtracer.putter. Okay. If auto tracer, and how about did Syscall or log Syscall? Is it did? No, it's not really did. Actually, it's cooler if we do it here, because then we can say did, and then we can also include the return value. Wouldn't that be even better? Didn't even think of that. Okay, so let's see. So let's give him the function, the arguments, and the return value. Cool. And then actually, we're gonna have to grow this by 1. And also include the return value. Okay. And let's do a little bit of setup stuff before we get to making the tracer. So here we need a file descriptor to be able to create itself with a tracer. So we just gotta make these construction functions. Process tracer, tracer, move tracer. Okay. And then end device. So I think we have a couple of places where we do this type of thing. Yeah, so say if m tracer. I mean, I'm just going to put these in here so that we can find them. Can write tracer return false. You can never write. But I always forget the semantics that we should allow writing and then we should fail if you try to write. Can you read? And tracer can read. And the entire file. Let's not care about that. That's just a silly helper for KSIMs. And what else do we have? Oh yeah, this absolute path. This is used for the proc PID FD entries. So let's see if tracer then return string format tracer, and we will put the PID here, the thing that we're tracing. And tracer PID. Okay. Supports mmap, and tracer return false. Definitely don't support mmap. Oh no, nobody's gonna truncate this thing actually. But if they do, then they'll have to assert, and we'll figure it out then what to do. Okay, can read. We need can read, and we need write needs to just fail. Maybe even eperm. Is that good? Eperm. IO error. I don't fucking know what the right error code is. Makes me figure out what the right error code is. We'll just say EIO for now. And then when we read, let's say tracer read buffer count. Yeah, I think that's fine. Okay, so what did we add now? tracer, we have can read, PID, read, and did Syscall. Okay, let's add this thing. So let's call it process tracer. And we'll add it to the make file. Process tracer. Process.cpp. This one was supposed to be ensure. And the other one already existed. And then here we need to call ensure tracer. And we need to import a header. Okay, let's make the thing. It was supposed to be retainable. Okay. Public retainable process tracer. Wait, is that how I write classes? don't remember how I write classes. How the hell do I write classes? Null device. What do you look like? Like that. Okay, good. Static retained process tracer. We need to create a function here because for retainable objects, we need to have a create helper. Otherwise, they're going to have the wrong retain count. So let's see, t, and then we'll just do this. Return adopt new process tracer PID. Okay, retained. Okay, PID. Let's see. So what kind of members do we need? I guess we need, I mean, PID and PID. And let's see, process tracer. PID and PID. And let's have a destructor because everybody needs a destructor. And then we need a good Syscall. Dword function, dword arch1, dword arch2, dword arch3, dword return result. Yeah, I can't call it return, obviously. Actually, yeah, so I'm gonna change that here right away because it's gonna annoy me otherwise. Okay. Process tracer. And let's see. No constructor, right? Because I didn't define it. And now we're gonna have a double buffer for the for the actual data stream. So double buffer is a handy kernel class that allows me to have a buffer that can be read and written at the same time. It works by having two buffers internally and then flipping them. Pretty handy. So let's say that m buffer right. Yeah. So let's see, dword beta 5. This is a little hokey, but whatever. Arch1, Arch2, Arch3, data for is result. Okay. And that's the size of data. Yep. Okay. And then we need to add bool can read const buffer, I think, is empty. Is that? I think that's a way to do that, actually. And then let's see. I just realized that we're gonna need to wait for this thing to say that the process is dead. So return I'm dead. Bool I'm dead. False. We'll say void set dead. And that is true. Okay. And we will just put that in process. It's a die. In process die, we will say if mtracer is set dead. Okay. And then we also need int read white the buffer and yeah, like that. Buffer size, and then we'll return end buffer read buffer size. Cool. So why am I so optimistic about this whole thing? Well, for one, I am screwing that part up. So I'm not actually passing the process by pointer. Tracer creates. I don't even know if we need the PID for anything. I'm just putting it in there because it felt like I might need it. Okay, let's add some forgotten includes. Process tracer. Kernel seems to be building, except I didn't spell process tracer right in the make file. And okay, so expected constructor, destructor, or type conversion. Did I forget something in the process tracer header, perhaps? Double buffer, right? Wait, how did? Okay. Const byte size t. Const byte. Why am I so blind? PID t does not name a type. Alright, you know what? Screw you then. I'm not even going to have any PID in this thing. It's just going to be empty. I don't want to deal with PID t right now. Oof. Go away, PID. Oh, now I remember why I needed it. It was for the file descriptor absolute path. Alright, I'll be nice about it. Where the heck is PID t? Is it in kernel Unix types? Yeah, that's where it is. Okay. Oh, forgot to include it here. File descriptor.cpt. Okay, process tracer. Wow, it's built. Okay, let's build the strace program as well. Undefined reference to Systrace. Well, what the heck did I call that thing that I made? Systrace. Oh, right, I have to build everything because let's just build everything. Forgot to build libc, that was the problem. Am I optimistic about this? Kind of. We don't do anything with the dead thing, so let's say buffer is empty or and dead. And then here, let's see if buffer is empty, if I'm dead. Well, let's just return 0. And yeah, because if we're dead, then we will try to read with an empty buffer and we'll just return 0. Which will be end of file. Okay. God, I have no idea if this is going to work. Let's trace the terminal that we're in. Android is not size of call. Well, I wonder what it was then. Android is how much? Android is 1. Well, we're getting something. That's curious. Okay. Well, process tracer. Let's see. Size up there. Why don't we just add a little thing here? Did Syscall added the bytes tracer. Okay, buffer bytes in right buffer. Does that make sense? Buffer. Yeah, that makes sense. Okay. Oops. And what the heck did can read do again? Okay. Well, we're certainly adding a lot of info here. Oh, geez. Somebody's gonna need to pick up all of this stuff. Okay, let's see what went wrong then. Let's inspect one of those thingies to see what it actually ends up containing. Let's strace the lookup server. That one is chill. And cd proc. Cat FDs. Tracer 5. Okay, so file descriptor number 4 here is tracer for 5. And 5, of course, is the lookup server. And that's all good. So we know that this thing is a tracer. So we should end up here. We read and tracer read. Okay, see tracer read. Buffer empty, no, oh yes, and buffer is empty. Hold on. Let's do it this way. We need some printf here. Okay. Let's figure this out, guys. Did you even try to read this thing? Did we ever get here? I feel like we're not getting here. Why are we not getting here? File descriptor. Can read. I'm a little bit suspicious that I did something very incorrectly. Let's see. So what does the read Syscall do? Oh, we should probably say that, oh, we need to say that it's blocking, actually. So let's start with that. Systrace. Yeah, these descriptors should always be blocking. I mean, maybe they shouldn't be, but right now they're going to be. Whatever. How do we even get nred 1? How does that make any sense? So weird. Okay, you know what? Let's not care about that. So I guess that it's blocking. There we go. Otherwise, I try to read. And what the heck am I messing up? Read from the file descriptor. Hey, hold on. This is... Aha! See what I did here? I'm returning 0, where I'm supposed to be returning the frickin' file descriptor. That's goofy. What a stupid problem. Okay. Now we can actually read from the thing, and oh my gosh, look at all those syscalls. Jesus. I guess tracing the terminal that we are in is kind of an exercise in always having something to do. So let's start a new terminal, and we'll say, oh geez, who the heck is this terminal then? I guess it's number 11. Yeah. Okay, so let's say strace 11. Nothing's happening. I mouse over it and get some events. Oh, cool. And see the blinky cursor there? Causes syscalls. This is very cool. It would be nice though if we could see what the heck these syscalls actually are. And I think that is kind of not that difficult to add. So, because I feel like I have a helper for that. So we'll just do like a little bit of niceness here, and we can say equals, and then this is called toString. Yeah, that's the one. Function. syscall function. And yeah, userland sync. Okay. Make a new terminal. It's pig 10. Strace 10. Oh yeah, look at that shit. How cool is that? You can actually see the syscalls. Got a little bit of that get time of day going on whenever we are blinking the cursor. See? Ooh. How very interesting. Let's try it on someone else. How about the Windows server? This thing is very, very busy. Of course, running this thing that prints out shit all the time is going to make it very busy. But this is super rad. Okay, so let's do a little bit of, I guess a little bit of pretty printing here. We'll say like that, or no, let's use hex for outputs. User binand. Oh, do I want to format this thing? No, I think that's fine. Okay. Now we have a whole bunch of debug stuff that I don't want to keep, so let's go through that and remove it. Then we can look at the patch. Debug printf. Debug printf. Okay, so let's review the patch. We are adding a new way of creating a file descriptor that contains a process tracer. So it's yet another thing that can be the backing of a file descriptor. And then we delegate to the tracer in read, write. We don't delegate in write actually. In can write, we just say true, and then that will fail. In can read, we delegate. And in the absolute path, we say tracer column PID. Supports the map no. Then adding the headers for that, or the declarations. To the kernel makefile, and then in process die, we detach the tracer. So yeah, we didn't actually end up testing that, so let's see how that works. So this is PID 10. And what happens if it dies? It just closes. Very, very nice. Okay. Here is the Systrace Syscall implementation in process. So disable interrupts in order to be able to access the process table here. And then check that we actually find a process and that we have the same user ID. And then we allocate a file descriptor. If that fails, then no luck. And finally, we create a file descriptor wrapping the tracer for the peer process and set that on the file descriptor. Yep. And here's the ensure tracer. So if a process doesn't have a tracer, if you call ensure tracer, then it gets a tracer. That's fine. Here are the declarations in the process class. mtracer is a retain putter. It will be cleaned up on process exit. Oh, that's fine. I think it's fine. I guess actually one thing that we should fix about this is Syscall. In did Syscall, let's say if m buffer bytes in write buffer. Let's say if we have more than a page, then screw it. Somebody has to read all that gunk. Is that fine? Or do I like this? Do I like it? I guess that's fine. Or is this fine? No, this is not fine. We're going to use a different class. We are going to make this into a circular queue instead. Okay, and then circular queue of call data, and we will store, I don't know how many, 4096 divided by 20, say 200, fit in the page. And calls is empty, and call data is just going to be a struct call data, and it would be dword function dword. Because if we don't do this, then this whole thing is going to fill up and just keep filling more and more, and that's no good, because once you start tracing a process, it will always be traced with the current state of things. And actually, that's something that we should also fix, but not for this patch. But this is such a this would be such an oversight to not have a strategy for when we fill up the buffer. So let's say that call data, I guess we can just assign it this way then, kind of comfy. That. Okay. And const data, size of data. But instead it's going to be m calls nq data. And here it will be, how do we do this? Auto data is m buffer and calls to q. And then buffer size data. Wait, what the heck am I doing? Size of data. And we'll assert, because I'm lazy. Fix me. This should probably not be an assertion. Column is empty. Good. Wow. Does any of this work? Who knows? That didn't work out. Oops. Oops. So we have a strace 13, a strace 11. Yeah, this thing just dies. Why does it die? Is it because can read? We'll say if it's empty. Why doesn't this work? Can read. non-empty. There's no size. And calls size. Yeah, yep. Case the DQ'd, Q. And why does it exit? Oh, I'm silly. I'm very silly. Right. I have to actually return the fact that you read something. Yeah, strace 8. Here we go. Now this thing will never fill up more than 200 of these calls, and then it will throw away the oldest ones and only keep track of the new ones. I think that's good for this patch. So stuff that we didn't review was the Syscall in libc, adding the Syscall to the Syscall header. And when we do get a Syscall on the trap entry, we check if there is a tracer for the current process, and if so, we call did Syscall on it, passing all of this stuff. And here's the dispatch for SC Systrace. Yeah, so the thing that we changed now is that we switched out the double buffer and instead used the circular queue. I think that's cool. So let's commit this and say, oh, hold on, I'm adding new stuff. Process tracer. Kernel. Add a systrace. Syscall. And implement bin strace using it. Calling Systrace pid. Gives you a file scripter with a stream of calls made by peer process. The process must be owned by the same UID calls. Cool. Let's push that and play with it some more. Let's see. Do I have this neon cat thing? I do. Okay. That's pretty cool. Let's see what it's doing. Wow, there's a lot of writing going on. I guess that's what you would expect from something like this. Oh, shit, mode the pid. It's very cool. I like it. All right, so I think that is gonna conclude today's video. So if you made it this far, then I thank you for watching, and I hope you saw something interesting here, and I will see you next time.